parameters for that function. And lastly, you should be knowing. Hello everyone, I hope you all are doing great. My name is Anjali and I'm an educator at Tree Level by Unacademy. Our today's topic is basic constructs. In basic constructs, what and all we are going to do? We are going to do some advanced problem solving, which are going to involve functions. So before jumping into the problems, I will be giving you some brief overview about functions so that you will be aware about what and all we do in that. So let's get started. So in functions, what it actually says, the word function and the word functionality. So what we are going to do, whatever we are going to see that, okay, these things are actually exhibiting the similar functionality, we are going to club them together. So what basically a function is, that is nothing but clubbing the similar functionality stuff together. And how we have to give the function name. So whenever we have to give a function name, it has to be meaningful. So if we are creating a function, let us say I want to do two things in my question. First thing which I want to do is calculating the sum. Like in my question, like these are the two things which I am planning to do. And the second thing which I want to do is printing the sum. So here, if you will actually realize, we can actually create two sums. Sorry, we can create two functions. So one function is going to be for the sum, another function is going to be printing the sum. Now you can actually have a question. If we can just write our code outside, in such a case as well, it is going to work as expected. So what is the need of putting it into a function? So when we have to, talk about writing any program for any organization, in such a case, we also follow some of the design principles. And design principle says you always have to reuse your code, right? So it says we are creating a function. So whatever that function is actually stating to do, you should be doing only such things inside that, and you should be creating your functions in a way that anybody else can come and actually reuse it. So we have to think about the reusability and single responsibility. So these are the two things which are coming from the design principles. Okay. So here what we will do, one function is going to be there for sum and one function is going to be for print. Now you can say if we are calculating sum, here only we can actually add one statement which is going to just print it out. What's the point of having the separate function for print? So like usability, if you are just going to create a function which is going to do the sum, you can use it at multiple places. If you are going to add some condition here, so like condition as in, let us say after doing the sum you are printing it out, or you are doing some other things on the top of that, in such a case this function will not be reusable in all of the cases, because not in all the cases we want to display it on the screen. Probably we just want to do something else out of it. Similar thing goes with the printing. So if we are just creating a print function which is going to print some values on the screen, in such a case, if you have one print function, you can pass it on any set of values and it is going to just print it out for you. So you do not have to create separate functions for printing separate values. So what you are actually achieving by this, you are actually avoiding the unnecessary repetitive code. What you are doing, you are just writing it down at one place, and with that one place you are actually getting benefited out of it. Correct? So that is what we are achieving here. Now what I will do, I'll just take you to the Visual Studio Code and we will write a quick code for it. Okay, so let us say I'm actually having two numbers, or three, let us say. One, then I have two, then I have number 3, and this one is having 3. Okay, and then I'm creating something like sum. Okay, initializing it to 0. But I want to create, like I actually have two things to do here. So the first thing is sum of number 1 and number 2. And the second one is, which you want to do is sum of number 2 and number 3. So if you are not going to create functions, what you will have to do, you will have to write on repeated statements. Instead, what we can do, we can just create a function in a way that it is going to serve both of our cases. Now, when we have to create a function, we have to define a body for it. And when we are going to define a body, we'll have to take care of two things. First is where you are going to create your function. The second one is going to be what all values you are going to pass there. And that we actually say by parameters. That what are going to be the parameters for that function. And lastly, you should be knowing when to call it. So let us say you are creating a function, but you are never calling it. If you are never going to call it, is it ever going to run? Answer is no. And the basic example, if you are getting confused with the terms of functions and all, let us say you have a room of people. And if nobody is calling your name, are you ever going to react on anything? So let us say in that room, everybody is calling a number that, okay, A, after saying that name A, the A person has to get out of the room. If nobody is calling your name, will you ever come out of it? No. So you are not going to do the things which you have to do. So in such a case, what we will have to do, we will always have to call it out. If we are going to call it out, it is going to do the exact functionality which we are expecting out of it. So, in the previous JavaScripts, we used to create our functions in a different way. I will be showing it to you in both of the approaches. Okay. So how the earlier functions which we used to create, that one used to start with the keyword function. So we used to provide a function name, like firstly function, then we have to provide a function name. So I can say sum of values. Some name I'm just giving it to it. Okay. After that, like I said, you have to provide some value. So let us say, I'll take up that same scenario again. You have a room set of people, and in that, if I'm going to call out some name, let us say A, I actually have to hand it over him some notes. And after that, only he is actually going to go outside, and those notes he is actually going to use for his exams or anything, like wherever you want to actually use it. But we have to provide it some value, right? So here also, if we are creating some function, we have to provide it some value. And that one we are going to create, let us say n1 and n2. Now you have to consider one more thing here, that is, if we ever create a function, then we pass it on to values. These ones we call as parameter. And not necessarily it is going to be same as how you have declared your variables. It may or may not be same. One more thing, if you are going to do something inside this, that value is going to remain only inside this function. If you want to access it outside, you will have to return it back. So what does it mean? Let's take the same scenario again. You are giving notes to somebody, okay, and that person is going outside the room, and those notes are actually for some of your exams. If after exams, what you are expecting after the person is doing the exam, that person is going to return it to you, so that now you can give it to somebody else to study from that, right? So, or you can consider the example of library. That is what it happens, right? You go, you take a book, once you return it, somebody else take it and that person reads. So same thing we have to do here. After we are done with our functionality, we have to return the value. And why are we going to return the value? Because somebody else may want to use it. So it's always a good thing to return a value. Again, how you are going to decide if you want to return it or not, based upon what you want to do in your given question and how you are going to make that decision making. Eventually, with time, it actually gets easier for us to find out how we can achieve it. All right. So here, let's declare this sum inside it. Okay. So this one, what it is doing, we are defining sum variable. Okay. Now what I will be doing to this sum, here only I will be adding number 1 and number 2 to it. Correct. Now if I want to access this value outside, can I? So now if you just write down here sum and then you run. Is it going to work? No. Why it is not going to work? Because this scope is only live within this function. If you want to call it outside, what you will have to do? You will have to call this function. So let us say here I'm calling this function sum of values, and here I'm passing number 1 and number 2. So when you are going to call a function, you will have to pass on some values as the parameters it is expecting to do. Correct? Same goes with that library example, right? If you want the person to read it, you will have to give him some book, right? Then only he or she can read, right? So now if we are going to run, will it actually work in the same way? Let's run and see. So answer is undefined. Why it is giving undefined? Because here what we are doing, we are just taking one variable and that variable is adding two values. So what is actually happening? A person is reading and that's all. That person is not returning that book back. If that person is not returning that book back, can another student come and read that same book again? Answer is no, right? Because it is not at all available. If you want to make it available, what you will have to do, you just have to add a return statement. So you can write some. So what it is going to do in our case, what I said, after reading it, he or she will have to return. So with this return keyword, we are returning it back. Now if you will run, you can see it is printing sum as 3. So it is working correctly, right? So this is how earlier functions used to be written. Now what is happening? We are using some arrow functions. And how we define arrow function? In that they say you get rid of this function first of all. So there what we do, we just define it like how we define a variable let. And instead of doing it inside, instead of providing a function or anything, that is how you can do. So with the help of this, now you have a function whose name is sum of values. And since I said it is going to be arrow function, what you will have to do, you just have to put one arrow after it. It also says that whatever you are trying to achieve it with this, you can actually do it in one statement. How? Let me first run and show you the output for this. So you can see it is giving 3. That is correct, right? How you can short it down. So instead of taking one variable sum, what you can do here only, you can do sum of those two values and return it back. So you can see it is returning the value as 3. Correct, right? Now what it says you do not actually require these braces if you just have one statement. So if you do not have anything, what it is going to be there? Just return. But it says you do not even need this return keyword. This arrow function is going to do all the work. So you can see whatever things we wrote in some 3-4 lines, that one we are actually doing it in one line. Now if you will run, you can see it is printing the value as 3, which is correct, right? That was expected one. Now if we want to create another function to do the sum of number 2 and number 3, what you will do? Are you going to create another function? Answer is no. If you really want to do sum of those two values, what you can do, you can call this function again. And now when you are going to call it, just pass on the updated parameters. So here you can actually call sum of values. And with this, what you are going to pass here, what I am expecting, sum of number 2 and number 3. So here you just have to pass number 2 and your number 3. With this, if you are going to run, you can see it is actually returning the values. Correct? That is how it is going to work. Now, I was saying that you can actually have print values. So how the print values is going to work? So here, even though like we were returning the value and same one I'm displaying, this one is not printing anything within it. If you will actually realize what we are doing, this one is returning it and that value we are displaying it. You can actually have one more thing, that what if you just wanted to do third thing, sum of number 1, number 2, number 3. Now you can say how I can do this sum. So even in the general form, if you have 3 numbers, how you are going to add it on? First you are going to add 2 values and then with that you can add next value. Correct? So what we will be doing, firstly I am going to take one variable. So let us say sum 1. In that what I am going to do, I am going to call this, and here I am going to pass number 1 and number 2. After this what I will do, I will say whatever sum we got here, like from 1 and 2, what is the sum which we will be getting? 3, right? After having that 3, what we will have to do, that sum we have to add to number 3 and that is going to return the final sum, right? So how you will get the final sum? That is going to be, call this out with sum 1 and number 3. Now, after having these values, now it is there in this variable. If I want to print it out on the screen, how I can do for the printing it out, I have to create one print function. And how I can create a print function, I'll create it here only, okay? So let print values. So here what you want to do, you are actually going to pass on some value, and in return, what you want to do, you just want to print it out. Correct? That is how you can do. It's up to you how you're going to provide a body. If you want to do more than one statement, you have to put it into curly brackets. If you just have one statement, you can just do it with the help of arrow statement, right? So here if I want to print out, what I will be just doing, I'm going to call the print values, and here I'm going to pass on the final sum. But before that, what I will do, I'm just going to call it out for another, like all numbers, so that I can know, okay, what and all numbers I had, and is it actually working as expected or not. So now if you will see, with one function, I am actually passing different values. Here also with one function, I was passing different combination of values. Now if you will run, you can see like this one is coming from these two statements, and from this it printed all the three numbers first, and in the last one it has printed the final sum. So you can understand how we can write down the arrow function and how we can actually reuse the code. And if you are going to reuse your code, what you are actually trying to achieve there, you are trying to save a lot of your time in writing down the code, which is not at all required. Otherwise, what you have to do, since here we are doing lots of sums, every time you had to write down a separate function or something, which is not required. We are just using it, and this is serving most of our purpose. So I hope with this one you will be little bit clear about what the functions are, what return statements are, and how you can actually be fully like how you can actually fully understand this topic. Just give it a try. If you are going to write down one or two programs like how I have written, just small ones, you will understand it completely. Okay, you just have to do like we talk about maths, coding is also like that. You have to put little efforts on your own. You just have to write it down, you have to analyze how the output is coming, then you will understand it completely. Just by listening to a lecture or attending any class, you are not going to gain 100% knowledge. 100% knowledge you will be gaining after you are trying it out. Okay, so now let's move into the question. What the question which we have here, this one is saying that write down a function to compute cube root of a given number. So what does a cube root? So you must be aware about square roots and cube roots, right? So if we have something like 3, what is going to be the cube root for this number? What I will do, I'm just going to use the calculator and show it to you. It should be 1.732. Okay. But you are anyway aware about, if you have to find out cube root of 3, what it is going to be there, it is going to be 1.732. If you want to find out the cube root of this function, what you can, of this value, what you can do, you can use mathematical operation. What the mathematical operation which is available for the same, that is, if you have a number, apply like for the square root we will apply sqrt, for the cube root we apply cbrt. Now I will be showing it to you how it is going to work, and now I'm going to actually create a function for that. So let cube root, and I'm going to give it number 1. Why I'm going giving it this number? Because I'm going to do it using two approaches. Okay. So here what I will do, I'm going to pass on some number, and then I said you have to use the arrow function, right? And later on what you can do, math.cbrt, and here if you are going to give that number, it is going to return you the cube root of that number. Later on you can have some print. So here I'm going to pass on some number, and what it is going to do, this is going to console out. Cube root is number. Alright, and here like I said, if you are going to create any function, you will have to call it out, right? So you are first of all going to call it out on number 3, and whatever you are going to get from there, that one you have to pass it to the print function. So when you are going to call your print value, this cube root you will have to pass there. So now let me run and show you the output. So you can see it is giving 1.
खाले दो एक खान
Okay, sorry. 1.732 is square root of 3. Perfect. What I will do, if you want to see the exact one, I will pass 8 here. So for 8, it has to be 2. So now you can see it is giving cube root is 2. Correct? That is how we can get it. So this is one of the approach of finding out the cube root using math.cbrt. Now, sometimes what people say, they say you do not have to use the CBRT. You have to do it in the another approach. So now I will be showing you how we can do it using the another approach. So this one I will be actually modifying. This is going to be nothing but 144 something we were getting, right? And if we have to calculate it for 8, it has to be 2. If we have to calculate it for 1000, it has to be 10. That is how we get cube roots, right? So first approach was how we were doing it using math.cbrt inbuilt function. If we have to do it using approach number 2, what we will be doing, we are going to solve it by binary search. So in this one, what we are going to do. First of all, we are going to define some E. That is for the error, and what we are actually referring by error, so all the values which are going to come after first decimal place, all that we are going to cover in our error. Okay, so what we will be doing for that, like to calculate the values after the decimal place. So first of all, define error E. After defining it, like how actually you have to define it, so it can be probably something like some bigger value, something like this. After defining this error, what we will be doing, we will be, like for the binary search, we are going to have some as the starting position and some as the ending position, right? So you will have to initialize your start and end. So initialize start and end. How you are going to initialize these two values? Your start has to be there from 0 index and your end has to be there till n. N is the given value, right? Now, what we do in the binary search, we calculate our mid value, right? So you have to calculate the mid value. How we can calculate the mid value? That has to be start plus end divided by 2. After calculating the mid value, what we will have to do, we just have to do one condition check. So we are going to check if the absolute value of, I'll actually write it here. So you have to check if the absolute value and of what, it is going to be n minus mid into mid. We are going to check it against this. Why are we multiplying it by 3 times? Because we are concerned about the cube value. We are checking out the cube, right? We are calculating the cube root. We are doing this and this is going to be this. So what is going to happen if you are, let us say, if your number was 8 and let us say you got mid value as 2. So in such a case, what is going to happen? N minus 2 into 2 into 2. That is nothing but 8 minus 8. And if we are taking this value, so obviously this is going to get satisfied, like some bigger value that is going to get satisfied. So in this condition, what we can say, if this condition is true, we are going to return true, and then we will say mid is the cube root of the given number. So in such a case, what we can say, if this condition holds true, then return mid as the cube root value. So basically what we will be doing, we just have to find out the mid, multiply it 3 times, subtract it from the given sum, and then you have to check it against this condition. If this condition is getting satisfied, you can say you found out the cube root. Otherwise, you will have to keep on doing, right? So I'll be considering the other case as well. If your mid into mid into mid, like you can actually get a mid. If you are going to multiply it 3 times, you will get that product bigger than the given number. In such a case, what you will have to do, then you will have to update your end. So now your end is actually going to be your mid. That is how we are going to do the partitioning. Okay, and if your mid into mid into mid, if we are going to do the cube of this mid and this one is actually less than n. So such a case, what you will have to do, you have to update your start. That is how you do even in the binary search, right? So exactly the same thing which we will be doing here. So then you have to update your start to mid. So this is what we are going to do. Now what I will do, I will take you to Visual Studio Code and we are going to write down the program for the same. And with the help of that program, you will understand it to a good depth that how we are actually going to find out the cube root using binary search. Okay. So what I will do, I'm just like this code, I'm just going to keep it as it is here. Okay. And for your reference, what I will do, I'm going to do it 2 times. Like here, I'm going to pass on the another value, probably 3 or 1000, some bigger value. And here I'm going to provide 1. And then the second one. So what we are actually doing, we are calculating the values like this. Okay. And if you really want to make it in the very readable form, you can just like put it into some numbers and then you can print it there. Like when I'm passing it here, I'm just passing on the same numbers, right? So you can see cube root is 2 and 10. That is what we got using the approach 1. Here I will console. Okay. Then I will be doing it using approach number 2. In this one, what I will do, first of all, I'm going to create a function and what that function is going to do. So that one is going to return us the absolute difference. And which absolute difference? Right now also when we were discussing, I showed you the absolute difference is going to be n minus cube of your mid. So that is how you have to do, right? So what we will be doing, let me just write it here only. So let cube root 2. And here what and all I'm going to pass? I'm going to pass my actual number and I'm going to pass my mid number, mid value. From where are we going to calculate that one also? I'm going to write it here, there. Okay. So in this one, what and all we will be doing, or to this, I'm actually going to name as difference because this function is actually going to return you the absolute difference. And whenever you have to give your function a name, you always give it a meaningful name. Okay. So what this one is going to do, this one is going to return the absolute difference of n minus mid cube. Alright, so here what and all we are going to do, we are just going to check it if your n is like, you remember I just shown you that if your n is going to be, if your mid cube, these points, if your mid cube is going to be greater than n, then you are going to update your end. If your mid cube is less than n, what you are going to do, you are going to update your start. So this is what first of all we are going to consider here. Okay. So if your n is greater than mid cube, in such a case, what we are going to do, you will have to update your start, right? And since this one we are just going to write for returning the absolute difference. So how we were returning the absolute difference through this, right? So what I will do, when I have to return, I'm going to return this value. All right. Otherwise, what we will be doing, if this value is going to be greater, then only you can have the absolute difference like this. Otherwise, how you will get the absolute difference? It is going to be actually the other way around. So in such a case, you are going to return it like this. Whatever value you have, just subtract it from n. So you can see how it is actually coming into the picture. So you do not get confused what we are doing here. If your n is greater, you have to subtract it from n. If otherwise, you have to subtract it from your mid value. Okay, like for the safer side, what you can do, you can just put it into brackets. Here also, let's put it into brackets. After that, what we will have to do, we will have to create a cube root function. So this is just to get the absolute difference. This is n. Or if you are defining that as number, update everywhere with number. Okay. Now this one is just returning the absolute difference. If we want to return the cube root, what we will have to do, we will have to write down one function for the cube root. So that is going to be let cube root, and here I'm writing 2. Why? Because this one is going to be the second approach for finding it out, right? Here what and all we have to pass? We have to pass your number. After passing on that number, what we will be doing, we are just going to set your start and end value here. So initially I told you start has to start from 0 and end has to start from the number which we are passing here. So let your start, that is going to be 0, and let your end, that is going to be the number. That is how we are going to initialize these values. Then we'll have to set some precision. So that when I said error, same thing. So either you set error or precision, like whatever you want to call it. Okay. So let E, and that one is actually going to start from 0.0001. So that is how we are actually setting our precision value. Then what we will do, we are just going to run it unless we are going to get true. And in this loop, what we will be doing, first of all, you have to find out the mid value. How you will be getting it? By adding start and end and dividing it by 2. After having the mid value, what we will have to do, we have to check out the absolute difference for the same. And how we can do it? By using this function diff. So we are going to just call let error, and how this error is going to get the value from the absolute. In such a case, what we say, mid is going to be the answer, correct? So this one we are going to consider now. So I will even write it here. If error is less than E, then mid is the answer. Okay, and in this case, what we will be doing here, we are not going to write it down in the same form. Why? Because error is actually doing the same thing, right? So we can just use this value here, and we can say if it is going to be less than or equal to E. In such a case, you have to return your mid value. Otherwise, what we will have to do in such a case, you just have to check for the other two conditions, these two. So if this is greater than n, then you have to update your end. If this is less than n, then you have to update your start. So these are the two things which you will have to do here. Okay. So I'm just going to check if your mid into mid into mid, if these values is less than n. In such a case, what you will have to do, you have to update your end, right? So now your end is actually going to be equal to mid. Otherwise, what we know, your cube of mid is less than n. In such a case, what we will be doing, we are just going to update our start. And for how long we are going to run it, in one of the scenario, this one is going to get true. If this is getting true, this is going to return the cube root value. Okay, so now what I will do, I'm just going to call this one again. Here I'm going to do 3, 4, some random values. Okay, and then I'm going to call printing. So here I'm going to pass 3 and 4. Now let's run and see the output for the same. So you can see, using approach 1, the cube root which you are getting is 2 and 10. And by approach 2, what is the cube root which you are getting? 2 and 10. So using both of the approaches, you are actually getting the same value as the answer. So I hope you must have understood it. Now we can move to the next question.